So problem one is about just using your resources. That the resource to which I'm referring is, of course, your sheet. I'm sure you all have a copy of it by now, but the sheet that has all the powers and roots on it, right? Some of you have calculators that'll actually do logs with different bases, but we don't go on the assumption that you do. So if you just don't know what that is, just go find the answer to the question. 8 to what power equals 4,096? And it doesn't take long. Are we on the right one now? Is that right? Okay, good. So the question is 8 to what power equals 4,096? And you just search a little bit and you figure out that the answer is 4. If you have 8 and you raise it to the fourth power, you get 4,096, which is why that's the answer to that problem. So remember, as we do section 1 here, problems 1 through whatever it is, that we're just looking for the exponent that's needed to make the argument, like the answer thing, right? And so the question 2 is saying 10 to what power, because you can't see the 10, but of course you know it's there, equals 1 million. And with tens, the nice thing about tens is that you just count the zeros. And so since there are 6 zeros, the answer to this one is just 6. You have to raise 10 to the power of 6 to make a million. Tens and zeros are obviously quite interrelated there. Question 3, this was just this. If you missed this, it's just shameful. Sorry, but this is in your notes. It was literally in your notes. That one of these facts that I implored you to write down. The natural log of E is redundant. It's saying a log with a base of E of E. It's saying E to what power equals E? It's 1. That's all. The next one is another one that's just in our notes, that if we have a log, it doesn't matter what the base is. I could have put log base 426. It doesn't matter. If the argument of a log is 1, the only way to make that happen is to use an exponent of 0. 5 gets a little bit trickier because now we're dealing with fractions. Do you guys remember how we make fractions? What does it take? We need negative exponents, right? And so really what it boils down to is I look at my power sheet, because you probably haven't memorized all these. That's okay. So I look at my power sheet and I say 7 to what power equals 343? And you just scan it down and you go, boom, there he is. 7 to the third power is 343. And so the answer to this one, since it's 1 over 343, is just negative 3. You have to use the negative version of the number to get it to flip to the basement. That's all. All right, question 6 is another you got to know what you're doing kind of problem. I feel like you can navigate the first 4 or so without really knowing. And then now it's like, okay, I better have this in my notes. And so another way to write the 5th root of 8, I'll put a little box around it over here. Another way to write this thing in the red box is 8 to the 1/5. So what this problem is saying is log base 8 of 8 to the 1/5. And once you see it, if you understand logarithms, you understand how hilariously unmissable this problem is. It's saying 8 to what power makes 8 to the 1/5. You're like, are you messing with me? The answer is, well, 1/5. It's so obvious, it's almost difficult to believe that that could be the case. Question number 7 is another flipper. And the idea here is it's a combination of an invisible base problem with a flipper. The base is 10. And the question is 10 to what power flips to 1 over 100? How many 10s do I need? I need 2. But since they're flipped down, I need 10 to the -2. And then the last of what I would consider to be the simple warm-up-y problems is number 8. And again, it's redundantly simple. It's almost, you should almost want to not answer it just out of dignity and say, I don't want these points. You're insulting my intelligence. What power of E do you need to make E to the 14th? I'm thinking 14. So that ends the warm-up section 1 through 8. Do you guys have any issues there? Okay, on to number 9. And I say it starts to get kind of real at this point in time because, as you notice, the log base and the arguments don't match, right? So like if you look, I mean, I tried to put those so that you could look straight up to problem 6 and do some comparison shopping and say, okay, this is not the same situation. Things just went a little cuckoo. So what can happen? I'm going to switch to my other page so I can write a little bit. I don't know, it's just, for me, it looks better on the other page. So we have log base 5 of, was it the cube root of 25? So do you guys remember the key to problems like this? Absolutely. The moment you're not sure, and I'm sorry if I didn't make this clear, God bless you. The moment things start to become a little bit fuzzy for you, here's your bailout method, equals X. Just make sure you don't put X equals in your answer because there was no X in the problem. We put it there. So there it is. There to me is the kicker. So here I go. I'm going to say, I'm going to water cycle it out. So I'm going to put 5 to the power of X equals the cube root of 25. I didn't do any math at all. In fact, I haven't done any math in this problem yet. Why is this not workable in its current state? I said it once already, but what is it about this? Because the bases aren't the same. Right. So the idea here is, hold on, stop the press. This 5 and this 25 are not the same number. So I can't just directly hop out and give an answer. What I have to do now is I have to understand that 25 can be written as a power of his homie over here. What is 25? 5 squared. So if I take that 25 out right now and I erase it and I replace it with a version of the other guy, if I write him as 5, but with a power of 2, he still equals 25. But now I've been successful because the game of Operation Match the Base, I've won the game. I have a 5 and a 5. So on the left side, my 5 has a power of X. And on the right side, my 5 has a power of what? 2/3. Ask if you don't know how I'm getting that. No one's going to yell at you. No one's going to make fun of you. No one's going to point at you. Remember that each number in a situation like that has a job to do. The power of the 5 is the top of the fraction, and the index of the root is the bottom of the fraction. And at this point now, it couldn't be more obvious. Exponent has to equal exponent. The answer to this problem, 2/3. It's over. It's all about matching the bases. Okay. I think I'm just going to stay on this page and I'll just get the problems off of my packet here. So I like writing on this better than that PDF thing. So next one is log base 64 of 16. What is step 1? Equal it to X. Just do it. Right? As you prepare a new page of notes, which you should quite frankly already probably be doing like this moment, you start thinking about, okay, what are some things that I can write down? You can remind yourself, hey, starting at problem 9, set everything equal to X. It's going to help me. Because again, once I water cycle this out, I'm going to realize very quickly when I take 64 and I raise it across up to the power of X and I set it equal to 16, sorry to ask rhetorical questions, but what's the problem? What's the problem though? The issue. They don't match, they being the bases. Again, I have an issue with the fact that 16 and 64 are not the same number. So this is where now I use my resources and I ask myself, 64 and 16, what are you both powers of? Not 6. 4 is the best answer you could give. A couple people came up with 2, which actually works in the end. It just has a little bit more annoying numbers, but they are both powers of 2. 2 to the 6th is 64 and 2 to the 4th, but we're way better off if we use 4. If you can find a bigger common base, you'll have less annoying stuff at the end. So I'm going to take this yellow box and I'm going to write it as 4 to the 3rd. I'm going to take this yellow box and I'm going to write it as 4 to the 2. And you should agree that the 2 gold boxes equal the numbers below them. I haven't cheated at all. Now what I'm going to do is I'm going to take that X that was there up above, and I'm going to bring him down right here. He is a multiplier onto the power of the left side. And it happens again, and it happens quickly. The power of this equal sign says, hey, if the left side and the right side actually equal each other, then this exponent has to equal this exponent. There's no way around the fact that 3x has to equal 2. Divide both sides by 3. What's x? Done. And again, don't put x equals 2/3. Like if you have x equals 2/3, at least just put like a box around the 2/3. Not that, because the x again is like our creation, right? Okay. Any questions on that? Okay, let's head on down. Question number 11 is just more of the same. It's another issue of operation match the base. And so the problem starts out with a log base of 216 of 1 over 36. And again, I'm just going to set it equal to x because that's what I do. And when I water cycle this out, it's going to say 216 up to the power of x equals 1 over 36. And it's at this point, you set your pencil down, grab your piece of paper. You just probably know this one, quite frankly, but ask yourself, what are 216 and 36 both powers of? They are both powers of 6. So again, what I'm going to do is I'm going to not focus on the X. I'm going to focus on my gold boxes. I'm going to take this gold box and I'm going to say, I know you. You are definitively 6 to the third. And then I'm going to take this gold box and I'm going to say, I know you. You are definitively 6 to the what? -2. It's got to be negative. We know that 6 to the 2 makes 36, but we're like, wait, hold on, dude, you're hiding in the bottom. Well, I got a job. I got a tool for that. If I want it to be downstairs 36, I just make it 6 to the power of -2. No big thing. And then you take your X and bring it down and attach it to the correct side. And then you acknowledge and respect the power of that red equal sign. And you say to yourself, if 6 to the blah equals 6 to the blee, literally has to be true that blah has to equal blee. There's no way around that fact. So I'm just going to take my two exponents off to the side and say, hey, one of you is 3x, and you got to equal the other guy -2. Divide both sides by 3, you get x equals -2/3. So again, the answer is just -2/3. You okay, Maddie? Last one is question 12, and kind of more of the same is probably at this point what it will feel like. So I'm going to set it equal to x. So what it would say after I water cycle it out is it would say 25 shot up to the power of x equals the 6th root of 125. And I half apologize for having to ask this, but again, what is the issue? Why is this number 12 and not number 5? The bases don't match. What are 125 and 25 both powers of? They are both powers of 5. So I'm going Goldilocks again. I'm going to take this Goldilocks and say, hey, 25, I know you. You're 5 to the tooth. But before maybe I do this, perhaps, well, here, we'll do Goldilocks again. Well, no, I'm not ready for Goldilocks. What is this blue thing the same as? What is 125? Like, I want to know that every one of you can answer that question. Like, I know that there's always like 2 or 3 of you that always talk, but I want to know that every one of you knows that that blue bubble is the same as 5 to the third. We're all good with that? And I would do that because I want the 5 to match the other 5, right? So I'm going to take now this Goldie box and I'm going to write it down here as 5 to the 3/6. And of course, yes, I will reduce that momentarily. Any questions about that? So what's happening is, remember that 125, okay, so thank you for stopping me there. Maybe I went a little too fast. Okay, so 125, do you remember how, like, if I took x and I took like the third root of it, how that's the same as like x to the 1/3? You remember that? And if I had like the 6th root of 10, that's the same as like 10 to the 1/6, right? Okay, so let me go a little slower here, and let me take this green box, and let's agree, don't agree with me just to be polite, that that's the same as 125 to the 1/6, right? Okay, so you're good with that. So would you be good if instead of that, if I replaced the 125 inside and I called it 5 to the third? Are you okay with that? Promise? Okay, and do you also agree that once we see something written like this, that the 3 and the 6, they kind of like high five and then split ways and say like, hey, I'll catch you on the flip side. And the 3 says, I'm going to the top of a fraction. And the 6 says, I'm going to the bottom of a fraction. So you're okay with that? You sure? So that's why this side would be 5 to the 3/6. Always you can do that. No way. Totally. What we want to do is kind of avoid the fact we don't ever want to do the math and actually take the root of it. We're just kind of rewriting stuff creatively to make things match. Good. Any other questions on that step? It's a hard problem. And then what I'm going to do is right now, I'm going to take 3/6 since I'm a big kid, and I'm going to reduce it to 1/2. because why not, right? And then I'm going to take this x and go whoop, stick you down there. And I'm going to go again with my common sense and say, well, at this point, if 2 to the this equals 2 to the thises have no choice. They have to equal each other. So power on the left must equal power on the right. Divide both sides by 2. 1/2, if you have a half of a pizza and divide it in 2, now you have a fourth of a pizza. So the answer to the problem is, well, 1/4. That concludes section 1. Do you have any questions about that? Better? Good? Let's head on then to that bottom section. Some of these I don't really need to see any work on, just for the record. I know that that's not really normal for a guy like me, but if you understand logarithms, question 13 is really just asking you a very simple math question. What it says is this, and I'll write this out. If I water cycle this out, this is for those of you who put 72, which hopefully that never happens again. What this is saying, if I water cycle it, is x to the power of 2 equals 144. And what number could you square to make 144? 12. And you might say, well, why is the answer not also negative 12? And the reason is because if you try negative 12, it just doesn't, you can't put negative 12 as the base of a log. So that's why in this case, I would just go with the what we call the principal root, just x has to be 12. Normally negative 12 would work, but you can't do it here. The next question I think is just as simple. If you water cycle it out, it starts as log base 3 of x equals 5. You just have to know your fundamentals, and the fundamental, by some chance I didn't make this clear, it's this to the this equals this. There's that water cycle. I haven't drawn it in a while. So it says 3 to the power of 5 equals x. Oh, 3 to the 5th, I know that guy. That's 243. None. Question number 15. Again, if I see it in its current state, it's a logarithmic equation. I don't want it as a logarithmic equation. I want it as an exponential. So I'm going to say base to the power of x. I need you to equal 1 over 125. And if you can just relax and take a step back, it's really just asking you, what would you have to raise 5 up to turn it into 1 over 125? Negative 3. So x is negative 3. Question 16. Again, there's no real algebra to do here. The water cycle itself just presents this equation. So you don't have to do any air quotes algebra. The algebra, as we refer to it, is often the manipulation of like getting rid of things and like moving 4x to the other side. And so this isn't algebra, and this is just math. The x is already by itself. You just have to know what you're doing. So let's talk about that exponent on the 25. First off, the fact that it's negative, what does that mean? Yeah, all the action is going to happen in the bottom. So let's get that out of the way first. This negative sign, I'll put a little yellow circle around it, just means basically to take the action, the 25, to the power of 1/2, and please just relocate it to the bottom of a fraction. So there's step 1. What does the fact that it's a fractional exponent mean? Say again? Right. And what kind of root is it? A square root, a second root, a 2th root. And what's the 2th root of 25? So that's why the answer for this one is just 1 over 5. Okay. Still good? Okay. On to question 17. Again, I'm not going to copy it off the paper. I'm just going to water cycle it out and put 49. If I raise u to the power of 3/2, u equal x. And so again, sorry, it's not an algebra problem at this point. The algebra's done. It's just a math problem. I just have to hope and pray that I know how to evaluate 49 to a fractional exponent. What the heck is that? So let's talk about what everybody's job is. What is 2's job? He becomes the index. He determines the flavor of your root. So I say, okay, according to you, you need me to make one of these, a second root. We call it a square root. What is the job of this 3? He becomes the exponent. They just literally, it's 100% take it to the bank, reliable, what the top and the bottom of those fractional exponents do. You're never going to budge. Bottom is the index, top is the power. And now I just plug 49 in here and use my resources. So here it goes. Follow the white box. What is the square root of 49? So I take 7 and I raise it back up to the third and I get done, 343. So x equals 343. And I am putting x equals on these because I'm actually solving equations. X was part of the problem given to me, not my creation. Next one up, if I water cycle it out, in my humble opinion, undeniably the hardest question on the quiz. If I take the, bless you, if I take x and I cycle it up to the power across the way, I get x to the negative 3/4, and I set that equal to the argument of the log, which is this. And I look at this and I'm like, what? You got to have strategy for this. And I got one for you. Anybody know what it is? Birthday boy? Yeah, so what we're going to do is we're going to raise each side of the equation up to a power, and that power isn't arbitrary. We're going to do what Brady said. We're going to raise it up to the reciprocal power. So the reciprocal of the exponent that I'm trying to kill is another negative, but I got to flip it over to negative 4/3. And of course, in math, if you do it to the left side, you have to do it to the right side. So again, as your algebra teacher, at this point, I say the algebra is done. Algebra is that solving process, that manipulation. The rest now is just what we call arithmetic. It's math. So the 3/4 and the negative 4/3 or whatever they are, they cancel out and we're left with, okay, the problem is over. Now I just have to hope I do this right. Let's talk steps. And I would encourage you to think steps. What does this negative, I'm circling it in yellow, do? Sure. Yeah. So it takes the, yeah, but if it's already in the bottom, then it takes it back up to the top. Negative exponents are like kind of boring once you get that. They move things down, but if it's already down, then they move them back up and down and up and down. They're just floor jumpers. That's all they are. There's no like sub basement to this. If you're already in the basement, go back up. If you're up, go back down. I mean, so I'm going to take the 1 over 216 and I'm just going to give them an upwards flip and say, oh, your new name is 216. And your new exponent is this beautiful, shiny little 4/3. Notice the negative has been spent. It's gone. And now, just like the last problem, I ask you these questions. What is the job of that 3? He says, make me a root called a cube root. What is the job of this green 4? He says, I am your power. And what do? I well, stick the 216 in there and use my resources. What is the cube root of 216? 6. And what is 6 to the 4th? 1,000. Done. So x equals 1,296. Jared, you okay, Bubba? You sure? Got interesting at this point, really, I thought. Log base 8 of 4x. So the first thing you want to do, and again, anyone who might be watching this video or whatever would already have a copy of this, presumably, I hope. Maybe I'll go back to this. That's what I'll do. Actually, they wouldn't have a copy of it because I still have it, so I take that back. So what is going to happen now is I'm going to condense this, and I'm going to condense it by taking this and multiplying them together. I hope the right people are listening and not just like staring at me creepily, because that's like that is a memo that I think we all should have gotten. That when you have 2 logs added together, you multiply the arguments back up. So this condenses into a singular log with a base of 8 and an argument of 4x times 3, aka 12x. Step 1. Step 2 is to water cycle it out. And that means that I'm going to take 8. I'm going to raise it up to the power of 2. And I'm going to set that equal to the argument 12x. And then poof, divide both sides by 12. You get x equals, 16 over 3. Just, 64 twelfths, and then you just reduce it, divide them both by 4. 16 thirds. Next problem is infinitely more challenging, I think, for a couple of reasons. Number one, it's got an invisible base, which still bothers some people. It's a 10, and it also has a multiplication problem that we have to do. So what it becomes at this point, if I were to show as much work as I could, is it would be log base 10 of 3x plus 5 times 2x plus 3. So the argument of the log you see is a multiplication problem. I wouldn't normally show this much work. I'm just doing this as a courtesy to those of you that laid an egg here. So that's what the problem looks like. That's its condensed form. Now you got to know some basic algebra. You got to be able to multiply those two things in the red parentheses together. So what this becomes now is log base 10 of 6x squared plus 19x plus 15. And if you want to know how I got that, just take this problem. I'll put a green bubble around it, go off to the side and just go all algebra 1 on that little son of a gun and just multiply, 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 and you'll get the same thing. Okay. What do we do now? I love that you called it the waterfall. That is super dope. Let's waterfall that son of a gun. Yep, let's do it. So remember, that just entails now that I'm going to take the base of the log, the formerly invisible 10 that I very nicely wrote for us here. I'm going to take 10 and I'm going to raise it to the power of 0 from my notes, directly from my notes. What is 10 to the power of 0? Here's 1. So I'm going to say 1 equals 6x squared plus 19x plus 15. Not 0, not 10, 1. At this point, it's just a standard ho-hum, been there, done that quadratic equation. I'm going to leave 6x squared the heck alone. I'm going to leave plus 19x the heck alone. I am going to subtract 1 across to the other side, giving me 14. And then I'm just going to hope that I've done my due diligence and that I know how to factor. The factoring on this one shook out to be a 6x and a 1x. And then there was a 7 here and a 2 here, giving us a 12 and a 19, and they're both pluses. So what happens is now you get an answer out of each of those. The first one is going to produce an answer of x equals negative. Of course, it's negative. And you take the 7 and divide it by the 6. Make sure you do that in the right order. The second one pops out just a simple -2. And our job at this point in time now, I'm going to erase a whole bunch of my work. Our job at this point is to go now and plug those in and see if anyone breaks the law. And it turns out that -2 does break the law. If you put -2 right here where this little red arrow is pointing, what's 3 times -2? The -6 plus 5 is negative. And that's like one of the 5 rules we have, that you can't have a negative argument for a log. So -2 is breaking the law. He's out. -7.6, if you're uncomfortable with that, as I said a long time ago, just turn it into a decimal. When you go to put it in your calculator, just put it in as like -1.17 or something like that. That's good enough. -1.1667, whatever you like. But when you put it in, you'll see that he causes no problems. Everything's fine with him. So he gets a box. The other one got a cross. Remember, don't leave answers just naked out in the middle of nowhere. Box them if you like them, cross them if you don't. Don't leave it up to me. Questions so far? Okay, question number 21 is, there's just a trick. There's a who's paying attention trick. What do we want to do first? We really want to condense. And I hope you're listening. You can't. Why? There's a blocker. That's in your notes. If it's not, put it in your notes. You can't condense if there's a blocker. And the blocker to which I'm referring is this little guy in the red box. He prevents you from condensing. But, ooh, thank goodness I have a strategy to get rid of him. Where does he go? Yes, he does. He says, let me become an exponent and I'll get out of your way so you can do your cute little condensing thing. So what happens now is the problem actually is log base 9 of 2x minus log base 9 of 3 squared, which is 9. And at this point, if you're really savvy, literally no one spotted this, you could get rid of log base 9 of 9 and make it a 1. But I'm not even going down that road. We're going to do this like a normal problem where let's just assume that that would not happen. So here we go. Let's press on. Can we condense now? Yes, let's do it. So when I condense, I get a singular log with a base of 9. And this time I have to create a division problem out of the arguments because it's minus. And then I set it equal to the argument, which is 2. All that work was to get to the point where we've now earned the right to water cycle it into something we can work with. So take your base 9 and raise it up to the power of 2. What is 9 to the power of 2? 81. So our new equation is just 81 equals the argument of the log. From here, you're going to multiply both sides by 9, and you're going to get 729 equals 2x. You're going to divide both sides by 2. And you're going to get this big old butt ugly answer of 729 halves. You're like, what? But again, I'm not concerned with the math checking out. I'm simply concerned with, is he a lawbreaker? And I'm a big kid, and we're all big kids, and we know that if we take that big, big number, 360 something, and we put it in place, whoop, right there where that blue arrow is pointing, no laws shall be broken. So he gets a box. You okay? Sure? Nice. Let's head to the next one, number 22. On question 22, what are we thinking? What do we want to do? Can we condense? Yes, we can, because there's no blockers. So like, ha, they're scared of me now, no blockers. So when I condense this, I condense it into a singular log with a base of 3. And my argument is not going to be times, it's going to be like the last one, division. So I'm going to take the first argument, 4x minus 7, and I'm going to divide it by the second argument, x minus 2, and I'm going to set it equal to 1, because that's what the problem says. What's next? Hit it with the cycle, the conversion. A college professor would say, what is this water cycle? It's called converting it to an exponential equation. I don't know where. So you call it whatever you like. We're switching it over to the good kind. So I'm going to take the base 3, and I'm going to raise it up to the power of 1, and 3 to the 1th is 3. So I'm going to say 3, you equal the argument 4x minus 7 over x minus 2. And now all logarithms are gone, and it's just back to regular algebra. What do we do to both sides? We multiply by the quantity of x minus 2, like this. And on the right side, we go, so long, suckers. And what do we get on the left? We get 3x minus 6 equals 4x minus 7. And so the way I manipulate an equation like this, and you ought to now be to this point, I just move the 3x's over in my head to get 1x. I add the 7 across to get 1, and I'm done. Check that answer. Will it break any laws? It will. It breaks the laws in both logarithms. Right away, it makes log of a negative, which means it doesn't work, which means what? That we have to explicitly write, hey, there, the answer is no solution. The answer is that there is no answer. Question number 23. This deals again in quadratics. Some of you would maybe think that this is the hardest problem. I don't know. What you have to do is water cycle it right away. No condensing, no fancy stuff. It's just, let's convert it. So I'm going to take x plus 5. I'm going to show more work than I normally would in this case, just as a courtesy to a few of you. This is what the problem looks like in its water cycled out converted state, but before we actually start doing the math. So the left side is a square multiply double. What is x plus 5 squared?
X squared plus,
Totally. And if that's Leary and you're one of those people that doesn't know but just doesn't want to ask, it's just x plus 5 times x plus 5. Just multiply it out old school. Go x times x plus 5 times x plus 5 times whatever. It's just a shortcut. Square multiply double is just a shortcut. And we're going to set it equal to 3x squared minus 3. And then it's just business as usual. You just do your thing. I'm going to bring my x squared across and get 2x squareds. I'm going to bring my 10x across and make minus 10x. I'm going to subtract my 25 across and get minus 28. And then you factor it down. And I just divided everything by 2 because I wanted to, because I could. It's just one of those little tricks that the older you get, you just start looking for garbage like this. And if you divide all the numbers in this equation by 2, you actually wind up with a much simpler situation, which is x squared minus 5x minus 14. So little gift, take it or leave it, but I would divide every chance I get when something can be divided. Smaller numbers are always better. And then when I factored it down, I got x minus 7 times x plus 2. And then my answers were positive 7 and negative 2. And then, of course, I did my due diligence and I put them both back in. They both work. Everything's basically going to work here, except 0 would be the only thing that wouldn't work. Or 1, I guess, wouldn't work. But like these both are fine. You square them up, you're good to go. So they both get boxes. That leads us then to question 24. And question 24 is a condenser. So I'm going to condense it into a singular log with a base of 4, and it's going to be x squared minus 4 over 2. Step 1, done in the books. And for the 187th time, what do we do next? Yeah, waterfall, that son of a gun, you bet. I'm going to start saying that just because it's super dope. So if I take 4 and raise it up to the power of 2, what's 4 to the 2th? So I get 16 equals x squared minus 4 over 2. And I get 32 equals x squared minus 4 because I multiplied, there it is, by 2. Move the 4 over, you get x squared equals 36. So what's x? You need 6, and you do this time also need negative 6 because negative 6 will work because follow my little green circle here. You see it, right? If you put negative 6 in there, what happens? So it's okay. He's like, hey, I'll work too this time because I don't break any laws. Put me in there, I'm fine. So that's why they both work. Sure. Are you feeling better? Got it. And I'm sorry that I have to go kind of quick, but the clock, being my boss, tells me I hate to be a clock watcher, but I keep kind of keeping myself on pace. So don't worry, we got lots of days before Monday, okay? But I appreciate you saying that. So, all right, we ready for the last section? Okay. These are expansion problems, and anytime you see log of something times something, you immediately have to break it up into log plus log. Like that's just expansion 101. So there are multiple steps to this problem, but the first one is to break up the 10 and the m into they each get their own log. So the first one is the log of 10, and then I put plus the log of m. And if you got this far, you did a great job. But this again was a real tough one for me because I wondered like who actually looked at the answer key of the practice quiz to see, like I would want to know, why did Mr. Ahern get rid of that? Well, that's because what's log of 10? It's 1. That's in my notes. I know that log base 10 of 10 equals 1. And so part of this is simplifying as well. So we're going to simplify to 1 plus log of m. Got it? The next one is just a division problem, and division, of course, expands into subtraction. Remember that division and subtraction are cousins, times and plus are cousins. And so this is going to break into each part of the division problem says, I want my own log. So I said, fine, natural log of e to the 4th. There you go. You got your own log, big guy. And I'm going to put minus. And 100 says, well, I get my own natural log too. There you go. Is everybody happy now? No more fighting, kids. There you go. Far from done. What's the next thing we have to do? Not yet. Not yet. Let's do one more thing real quick. What do we do? It is, and let's talk about why. Part part of expansion is to take this 4. And the only reason I'm avoiding you guys who are saying 1 is because that won't work all the time. So I want to just follow what will always work, and then we'll get to that. If I take this 4 and move it down in front, your next line could have said 4 times the natural log of e minus the natural log of 100. And again, I'm happy if you got this far. You did lose a point, but that means you know what you're doing. But again, your notes or whatever failed you. What is this? Let me put a green box around it. Please, what is this? You got to know. That's in your notes. Make it big in your notes. Every time I see this, I'm putting a 1. Every time. 4 times 1 is 4. So the final answer should have been 4 minus the natural log of 100. Question number 27 has us dealing with just a bunch of crazy nonsense exponents and whatnot. So what I'm going to do is I'm going to first take this 2 and I'm going to feed it onto the 6, and I'm going to feed it onto the 4. I know those are kind of small arrows, but you can kind of see what's going on there. So what the problem as rewritten now is log base 6 of 6 squared times 4 to the 8th. Questions there? Now, again, remember the 6 is like a little kid and the 4 is like his annoying sister. They're in the back seat and they're like, we each want our own log. And you're like, fine, kids, I give you each your own log, no problem. So I'm going to take my property and I'm going to break it up. I'm going to say, okay, we're going to have a log base 6 of 6 squared. There you go. Are you happy, son? And then for you, I'm going to give you your own log base 6. And now 6 to the 2nd and 4 to the 8th, you guys, everybody play nice. What do we do next? Move your powers. Take all your exponents. Remember, expansion is just essentially reverse condense. It's just saying, let's make this as annoying as we can. So we're going to take the 2, shoot it down, and we have 2 times log base 6 of 6 plus 8 log base 6 of 4. And if you got this far, again, good job. Just lost a point. Why? What is this? What's the green box equal? 1. It's another redundant log. So I just get 2 plus 8 log base 6 of 4. Okay. I work for the school district, but really at the end of the day, I work for that clock. That clock is the thing that says that at 9:44, you are to be excused. You may hold on to those, but if you lose them, that's going to be a real problem for us, like a huge problem. We're going to finish going over these last few tomorrow. I'll do the same thing, record it, and then we'll probably do a retake on Monday. All right? I hope you've learned some stuff. Again, I had to go fast today because the clock said so, but if you want more time, just come see me. I'd love to sit and work with you and just one-on-one answer all your questions. After school, flex, you pick. There's no Friday school this week. I'm sorry. But after school, flex. If you want to come and steal lunchtime and eat in here, I'll make an exception this week. Whatever you got to do.